So we'll just start our next lesson in polynomial. The last class we have seen degrees of polynomial and polynomial value of the polynomial at a particular place when x equal to 1, x equal to 0. And polynomial at x equal to 0 when it is equal, the polynomial is becomes 0, x minus a is a factor. So this is the basis of factor theorem. So first we'll see the remainder theorem, when a function, so when a function, this is not a value. If when a function is divided by x minus a, remainder is f of a. When a function is divided by, so the division factor, so division factor is x minus a. So this value, what is the value of this value of a can be anything, a is a, so it simply represents a constant. This value should not be confused with the standard equation of ax square plus bx plus c. There a means some value of attached to the x square or x. So it's a constant. So this a value of a can be anything. When it's divided by x minus a, remainder is f of a. So we will work out some problems and we'll be more familiar with that. So when 2x square plus x plus 1 is divided by x plus 1, so what is the remainder is a function of a. A value of a is here minus 1. F of minus 1 is the remainder is equal to 2 multiplied by, no, minus 1 whole square minus 1 plus 1. So this will become minus 1 square become plus 1. This become values 2. So we'll actually divide the equation to x square plus x plus 1 by x1 x plus 1 and see. This is just to counter check 2x square plus x plus 1. When you divide by x plus 1, first factor is 2x square, no? So this is 2x. 2x multiplied by 2x is 2x square plus 2x. We get another 2x. So you minus it, 2x square become cancelled. X minus 2x will become minus x plus 1. Now the next factor is to composite minus x, you have to put minus 1. Minus 1 into x is minus x minus 2. Minus x, when you minus the second factor, this will cancel. 1, I'm sorry, this is 1, not 2. One minus of minus 1 become 2. And this is the remainder. So this is the divisor. This is the quotient. So I will tell you one more thing, this px, we can represent as this something like quotient multiplied by x plus 1 plus remainder. So we will represent as a remainder of x like this. So when a polynomial, this is we read like this, when polynomial x is divided by x plus 1, so we get some quotient multiplied by x plus 1, is it not? Plus some remainder of x. So remainder, when you say remainder x, it is just values 2. That's all. What about this one? Q is 2x plus 1 multiplied by x plus 1 plus this is quotient, this is remainder. Next problem, when 2x square plus x plus 1 is divided by x minus a. So this a should not be confused with the value of the coefficient of x square. This has nothing to do with this one. When you divide by x minus this some another constant, that is equal to f of a. Now we have to find out f of a is equal to 2 multiplied by and x equal to a square plus a plus 1 is equal to 2a square plus a plus 1. This is the remainder. Is the remainder. Next problem will proof for the remainder theorem. So when a px polynomial, be any polynomial of degree should be greater than 1 or equal to 1, and let a be any real number. When polynomial is divided by linear polynomial x minus a, this value should not be confused with this should be taken as a is any constant. Then remainder is f of function of a by remainder there. So polynomial x is equal to x minus a multiplied by some quotient of x plus remainder. In particular, when x is equal to a, what's happening? When x is equal to a, x minus a becomes a minus a. So PA polynomial of a is equal to here a minus a into quotient x, whatever be a minus a becomes 0 plus remainder. So only r is left, r is some remainder. What is the remainder? F of a. So polynomial, when you x is replaced by a, we get the remainder. That is all. So p of a gives remainder r. So what happens when remainder becomes 0? A becomes a factor. That is a fact. Next we will come to factor theorem. Next, find the value. We'll do some simple problem. Find the value of px at x equal to 1 or minus 1. So what happens? So p of 1 is equal to 1 square minus 1 equal to 0. So p of minus 1 will become minus 1 whole square. This also will become a 0. So what about x square minus 1 equal to x plus 1 multiplied by x minus 1. When x equal to 1, then the equation becomes 0. when x equal to minus 1 also this equation becomes 0. So 1 and minus 1 are the factors of the polynomial x. So it's also called 0 of the power. What is 0 of the polynomial? Polynomial becoming 0. That is all. 0 of the polynomial means find the term used is find the 0 of the polynomial. And the polynomial when the px becoming 0. So our equation gives px is equal to cx plus d, where c and d are all constants. So when you divide by pa, what happens? And it becomes 0 when you divide by pa. So pa, what is pa is equal to c multiplied by x a plus d. This will become 0. PA is becoming CA plus CD is equal to 0. When you divide by x minus A, so what is the value of the A? A is equal to minus D by A. So D and D are constants in the equation. So we'll go to next problem. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. First problem, x minus half is next problem. Okay, now two portions. So the first one we take as f of x is equal to x a is equal to minus 1. That your when you divide by x minus a is the f of minus 1 is equal to x cube is minus 1 cube plus 3 x square is minus 1 whole square plus 3 into minus 1 plus 1. Minus 1 cube is minus 1. Minus 1 square become positive 3. So it is plus 3. 3 into minus 1 become minus 3 plus 1. So the total become 0. F of minus 1 is 0. So what's happening? Therefore, x plus 1 is a factor. This is our inference. Find the remainder. Remainder is 0. The problem ends with here. Remainder is 0. Next to portion, f of its half. So this should be taken as x minus a. This also minus x minus half. So a is becoming half is equal to half 1 by 2 cube plus 3 multiplied by half square plus 3 multiplied by 1 by 2 plus 1 is equal to 1 by 8 plus 3 divided by 4. 2 square is 1 by 4. 3 by 4 plus 3 divided by 2 plus 1. If you take a common factor, 8 1 plus 6 plus 12 plus 8 divided by 8 is equal to 27 by 8. Or you can simplify, you can just leave it, no problem. Find the remainder. Next problem is, when x cube minus ax square plus bx minus a is divided by x minus a. So it's f of a is equal to a cube minus a multiplied by a square plus b multiplied by a minus a is equal to a cube minus a cube plus b multiplied by a minus a. This cancel each other, is equal to b multiplied by a, it's b minus a. This is the answer. So what we have seen mainly, remainder theorem is when a function is divided by x minus a, where a is some constant. Division factor is x minus a. Then the remainder is a f of a function of a. So to the polynomial, we apply the value of a and we get the value of the remainder. So we have seen the proof of the remainder theorem also. Any polynomial we can represent it as when you divide by x minus a multiplied by some quotient plus remainder. Some quotient of x, that's all we. In particular, when x is equal to a, the quotient will become 0. So the remainder p of a is equal to remainder r. So we have learned when for a particular value px is becoming 0, when you those values are becoming factors of the polynomial. When you divide by x minus a, f of a is becoming 0 and x equal to a is a factor. So when we say 0 of the polynomial, we mean at the point p x equal to 0, you have to find out. So when you divide by xa, for example x minus a, when remainder is 0, then a is a factor. Oh, see here, there's a small correction here. A is equal to minus d by c. I don't know that our students are so much attentive. They have noticed the mistake. Minus d by it's c. Here Ca is equal to minus d. A is becoming minus d by c. So this remainder theorem is very useful in factorizing, finding out the remainder factors we can find out. This theorem we use it frequently, so the students have to be thorough with the remainder theory. So students should repeat all problems again, to understand the basics. Please never forget to repeat the problems, till the concept becomes a part of you. So thank you all for listening the lecture patiently.